Right now, you reach down and tickle the bottom of your own foot. Nothing happens. No giggle, no flinch, no involuntary squirm. Yet if your friend did the exact same thing in the exact same spot with the exact same pressure, you'd be laughing before their finger even landed. Same touch, same nerve endings, completely different result. Most people just shrug and say, "It's because I know it's coming." But the real answer is far stranger. Your brain isn't simply unsurprised by your own touch. It's actively erasing the sensation before it ever reaches your awareness, deleting it like a file it decided you don't need to see. This isn't a guess. It's been measured directly, inside a lab, with a machine built specifically to tickle people. In the late 1990s, neuroscientist Sarah Jane Blakemore, working at University College London, built a small robotic arm with a soft foam tip attached to it. Volunteers could move a joystick that controlled the arm, letting them tickle their own palm by remote control, with a slight delay built in. The delay was the entire point. Even a fraction of a second of lag between the motion and the touch was enough to make the tickle feel real again, almost as ticklish as a stranger's hand. Why would a tiny delay change everything? Because your brain doesn't wait for sensations to arrive before judging them. It predicts them first. Deep inside your cerebellum, a structure tucked beneath the back of your brain, a constant forecast is running. Every time you move your hand, your cerebellum calculates exactly what sensation that movement should produce, and it sends that prediction forward to meet the real sensation when it lands. If the prediction matches the input perfectly, your brain treats the sensation as old news. It quietly cancels it out. This is called sensory attenuation, and it's happening to you constantly, in ways you've never noticed. Here's where the story gets even stranger. This isn't a modern discovery dressed up with new technology. People have been documenting the oddity of tickling for over a century. In 1897, psychologist G. Stanley Hall, working with his student Arthur Allen, published one of the first scientific papers on tickling itself. They noticed something curious while studying the phenomenon. Not all tickling feels the same. A light, wandering touch, like an insect crawling on your arm, produces a mild itch-like discomfort they call nysmesis. A firmer, rhythmic touch, especially in sensitive areas, produces the helpless laughing response they called gargalysis. Both of these depend on one critical ingredient: unpredictability. Take that away, and the entire sensation collapses. Think about what that means for your own body. Your skin has the exact same nerve density, whether you touch it yourself or someone else does. Your ribs are exactly as sensitive under your own fingers as they are under a sibling's. The hardware never changes. What changes is whether your brain already knows the touch is coming, down to the timing, the pressure, and the exact path it will travel. When you reach for your own ribs, your cerebellum has already simulated the entire motion before your hand arrives. It knows precisely where your fingers will land and precisely how hard they'll press. So when the real touch lands, your brain essentially says, "You predicted this, nothing to report," and dampens the signal before it can build into anything resembling a laugh. A stranger's hand carries no such forecast. Your brain has no internal model of their exact movement, their exact timing, their exact pressure. The signal arrives raw and unpredicted, and your nervous system reacts to it with full intensity. Because as far as your brain is concerned, an unpredictable touch on a vulnerable area deserves a strong reaction. Why would your body be built this way at all? This single mechanism turns out to be doing far more than ruining your ability to tickle yourself. It's the same system responsible for one of the most basic experiences of being a person, knowing the difference between yourself and everything else. Without this prediction and cancellation process running constantly in the background, you would feel every footstep as a fresh shock through your legs. You'd feel your own voice as if a stranger were shouting directly into your ears. You'd feel your eyes moving inside their sockets as a constant, dizzying blur. Your brain has to cancel out an enormous volume of self-generated sensation just so the truly new and external information can stand out clearly. Neuroscientist Christian Keezers and his colleagues, studying this same cancellation system in rats, found something remarkable. Rats can be tickled in a very real, scientific sense. When researchers tickled young rats on their bellies, the animals produced bursts of high-pitched ultrasonic chirps, the rodent equivalent of laughter, and they would chase the researcher's hand afterward, seeking more. But rats showed no such response when a mechanical device tickled them with identical pressure and rhythm. The social, unpredictable nature of another living creature's touch was doing something a machine's touch simply couldn't replicate. This tells you something important about why tickling exists at all. It isn't a glitch in your nervous system. It's a finely alarm for unexpected contact on your body's most defenseless areas, the neck, the ribs, the soles of your feet, places that are dangerously easy for a predator or attacker to exploit. Laughing under tickling forces you to curl inward, protecting those exact areas while simultaneously signaling to whoever's touching you that this is playful contact, not an attack you intend to fight. And here's the part that should genuinely unsettle you. This same self versus other prediction system, when it breaks down, doesn't just ruin a party trick. Blakemore's later research connected disruptions in this exact cerebellar prediction process to certain symptoms experienced in schizophrenia, where some patients report their own thoughts or inner speech feeling as though they belong to someone else, as if an external voice were speaking inside their head. The same mechanism that quietly cancels your self-tickle may also be the mechanism that, when it falters, blurs the line between your own mind and an outside presence. That tiny, almost comedic inability to tickle yourself is a visible symptom of one of the most important jobs your brain performs every second of every day. Now, think about how often this invisible cancellation shapes your life, far from any ticklish ribs. You don't feel your own clothing brushing against your skin all day, even though the sensors are firing constantly, because your brain predicted that contact the moment you got dressed. You don't notice the sound of your own footsteps the way you'd notice someone else's behind you in a dark parking lot. You don't flinch at your own heartbeat, even though it's a rhythmic thump against your chest wall every single second of your life. Every one of these is the same quiet erasure at work, the same forecast meeting, the same sensation, the same decision that nothing here deserves your attention. So the next time you try, half joking, to tickle your own foot and feel nothing happen, you're not missing some trick of technique. You're watching one of your brain's most essential survival systems do exactly what it was built to do. The very system that lets you walk through a world of constant sensation without drowning in noise from your own body. You're not failing to tickle yourself. Your brain is simply proving, in the smallest possible way, that it already knows exactly who you are.